When your network still feels like one big flat space where everything can talk to everything, you are carrying more risk than you probably realize. A single compromised laptop, a misconfigured server, or a stolen VPN credential can quickly turn into a company-wide problem if there are no real boundaries inside the environment. Network segmentation is one of those classic ideas that everyone nods along with, but in many organizations it is only implemented halfway or in ways that do not match how the business actually works. The result is a dangerous gap between how the network is drawn on diagrams and how it behaves when an attacker lands on a real device. In this Tuesday Insights feature from Bare Metal Cyber Magazine, we are going to walk through network segmentation in clear, practical language. We will talk about what it is, where it fits, how it actually shapes traffic, and how it shows up in everyday environments that include on-prem networks, remote users, and cloud. You will hear where segmentation genuinely reduces risk, where it is often oversold, and what healthy adoption looks like versus shallow, cosmetic changes. By the end, you should be able to look at your own environment and tell whether your segmentation is mostly on paper or if it would actually slow an attacker down. At its core, network segmentation is about deliberately breaking a large network into smaller zones that reflect how your systems, data, and users really work. Instead of having one giant pool of connectivity, you create boundaries so that compromise in one area does not automatically give an attacker a free pass to everything else. Those boundaries can be enforced with switches, routers, firewalls, software-defined networking, cloud security groups, or some mix of all of them. The point is not a specific product, but the intentional separation of different risk areas inside your environment. It helps to treat network segmentation as a design pattern rather than a feature. You can build it with VLANs, with routing instances, with traditional firewalls, with micro-segmentation agents, or with cloud-native controls. But they are all trying to achieve the same outcome. They control which systems are allowed to talk to which other systems and under what conditions. In practice, segmentation touches the middle of your stack. It sits between network infrastructure, identity and access, application design, and sometimes even the physical layout of your data centers and offices. A lot of confusion comes from mixing up network segmentation with related ideas. It is not the same thing as zero trust, even though many zero trust designs rely on segmentation as one of their building blocks. It is not just carving out a guest Wi-Fi network and declaring victory. And it is not automatically solved when you move to the cloud, because cloud environments still have internal networks, peering connections, and security groups that can be either flat or segmented. When you strip away buzzwords, network segmentation is simply about making lateral movement harder and more visible. You can think of segmentation in a few practical layers. At the broadest level, there is coarse-grained segmentation between major zones such as user networks, server networks, operational technology, or cloud connector networks. A level down is service or application segmentation, where you separate different tiers or components of a business service. And at the finest level, there is micro-segmentation, where you may define policies at the workload or even process level. Mature environments usually blend these layers rather than relying on a single magical boundary. Once you decide that you are going to segment your network, the first practical step is to define what the main zones are. In many environments, that means separating user devices, server systems, management interfaces, and any highly sensitive systems such as payment processing or industrial controls. Each of these zones becomes its own network segment, whether that is a VLAN, a subnet, a virtual network in the cloud, or a dedicated security zone on a firewall. The devices in between, such as routers and firewalls, enforce which segments are allowed to talk at all. Traffic between segments is where the real work happens. Instead of everything switching locally, traffic has to traverse a firewall or a routing policy that checks the source, the destination, and sometimes the application or user identity before allowing a connection. A simple rule might say that a workstation in the user VLAN can reach a web server in the application segment on port 443, but it cannot connect directly to the database segment. Those rules can be broad and simple or very specific, such as allowing only a particular service account to talk to a single port on a single server. A classic way to picture this is a three-tier web application. User devices sit in one segment, web servers in another, and databases in a third. Users talk to the web servers over encrypted HTTP. Web servers talk to databases only on the database port. No other segment can talk directly to those databases. If an attacker compromises a workstation, the enforced segments limit where they can go next, and their attempts to bypass the rules should leave a trail in logs and alerts. Even that basic shape gives defenders more time and more signal than a flat network would. Modern environments often add extra context on top of simple IP and port rules. In the cloud, security groups can allow traffic only from resources with certain tags or from specific managed services. Micro-segmentation agents can enforce policies based on the process that is making a connection, not just the address of the server. All of these tools are variations on the same theme. When traffic tries to cross a boundary, something checks whether that specific communication is allowed, based on rules that reflect how the environment is meant to work. In day-to-day environments, network segmentation shows up in a handful of familiar patterns. The most basic is separating user networks from server and infrastructure networks, so that everyday laptops and desktops are not sitting in the same broadcast domain as critical systems. Another common pattern is a dedicated management network that only administrators can access for device consoles, hypervisors, and backup systems. Even a small organization can benefit from putting user, server, and management traffic into different zones. Many teams go further and segment by function or sensitivity. You might see a segment for customer-facing services, another for internal business applications, and a separate one for development and test systems. High-sensitivity workloads, such as payment processing, health data, or industrial control systems are often isolated even more tightly, sometimes with one-way paths or jump hosts. Each segment can have its own access rules, its own monitoring expectations, and its own change process, tuned to the risk level and the business needs of that zone. For a lot of organizations, a realistic quick win is to isolate the most obvious risky combinations. Guests should not be on the same network as staff. User devices should not live in the same segment as servers. Production systems should not be mixed with development or test systems. Even if the policies between those segments start out simple, just having the boundaries in place makes it easier to refine rules over time. It also forces useful conversations about which systems really need to talk to which others, which can reveal hidden dependencies or unsafe shortcuts. More advanced patterns arise with microsegmentation in data centers or cloud environments. Policies might be defined at the workload level or even the process level, so that only a particular microservice can call a particular API on a specific backend. This level of control enables very fine-grained defenses around high-value applications and data. It also introduces new challenges around policy design, observability, and day-to-day operations. Organizations that do this well usually combine broad segments that create simple safety rails with fine-grained controls in the places where the impact of compromise would be most serious. When network segmentation is done well, it quietly shrinks the blast radius of almost any incident. A compromised workstation no longer has a straight shot to domain controllers, backup systems, or crown jewel databases. Instead, an attacker has to cross deliberate boundaries where controls, logs, and alerts can catch them in motion. That extra friction often gives defenders more time to notice odd traffic patterns and to intervene before the damage spreads across the whole environment. Segmentation also improves how teams understand their own environments. Defining zones based on function and sensitivity forces meaningful conversations about which systems really need to talk to which others. Those conversations often expose risky shortcuts, forgotten services, or misplaced systems long before an attacker finds them. They also make troubleshooting and change management more predictable, because traffic flows are intentionally mapped instead of being the accidental result of one flat network. The trade-offs are real and need an honest look. Designing and maintaining effective segments takes time, skills, and tools. Poorly planned segments can break applications, frustrate users, and drive teams to make a flood of temporary firewall exceptions that quietly become permanent. Network segmentation also has hard limits. It will not fix weak authentication, unpatched software, or unmonitored admin accounts. The most realistic view is that segmentation is a strong supporting control. It multiplies the value of good identity, patching, and monitoring, but it does not replace them. You can summarize the balance this way in your own mind. The main benefits are a smaller blast radius for incidents, clearer and more predictable traffic flows, and better visibility into lateral movement. The main trade-offs are design effort, operational overhead, and the risk of new failure modes when rules are wrong or out of date. The hard limits are that segmentation cannot replace solid identity controls, good hardening, or secure application design. It sits alongside those controls as another layer in the overall defense. Many of the most common failure modes share the same pattern. On the surface, the diagrams show neat zones and carefully labeled segments. In practice, the firewall rules collapse into any to any so that nothing breaks and no one complains. Another red flag is uncontrolled sprawl of exceptions, where nearly every rule is an urgent one-off change to fix a broken application, and almost none of them expire or get reviewed. In those environments, attackers experience the network as flat, even though the architecture slides claim otherwise. Shallow adoption also shows up when segments are drawn around hardware rather than around how the business actually works. All servers might live in one big segment, regardless of whether they support external customers, internal finance processes, development sandboxes, or sensitive data stores. When incidents occur, teams discover that an initial foothold has a surprisingly direct path to valuable systems, even though they thought they were segmented. That mismatch between design intent and real traffic is where many organizations get the worst surprises. Healthy segmentation looks quite different in daily operations. Traffic between segments is mostly predictable and documented, not a complete mystery. Requests for new connectivity follow a simple process in which someone explains which systems need to talk, why they need to, and under what conditions before a rule is added. Firewall or security group policies are reviewed regularly, cleaned up when applications are retired, and tied back to real business services rather than orphaned IP addresses from past projects. During incidents, responders can quickly see which segments are affected and which zones remain safely isolated. You can also observe positive signals in how east-west traffic is treated. Internal lateral movement is monitored and sometimes blocked for clearly malicious behavior, not just traffic going in and out of the internet. Sensitive systems live in visibly tighter zones, with fewer paths in and out and more scrutiny on each one. When new projects spin up, Someone asks early which existing segment they belong in, or whether a new segment is needed. Over time, these behaviors show that segmentation has become part of how the organization thinks, not just a one-time network project that everyone quietly worked around. At its heart, network segmentation is about shaping how systems can talk so that compromise in one corner of your environment does not instantly become a company-wide emergency. By carving the network into meaningful zones and controlling the paths between them, you turn a flat, high-risk landscape into something more layered and defensible. Segmentation sits alongside identity, patching, and monitoring as one of the foundational ways to reduce the impact of the incidents that will eventually occur. When you look at your own environment through this lens, the key questions become simple and concrete. Where are the real boundaries today? Who or what can cross them? And how would an attacker experience those paths? Even modest improvements, like separating user devices from critical servers or tightening access into a few high-value zones, can pay off quickly. From there, you can move toward finer-grained controls in the areas where shrinking the blast radius will make the biggest difference. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.